I'm about to meet Dr. Wang Yifang, whose name is synonymous to particle physics, especially for his work in neutrinos, the subatomic ghost-like particles that flooded the universe just moments after the Big Bang.
Hi, Dr. Wang.
Hi. Nice to meet you.
Hi. So nice to meet
Nice
you.
to meet you.
Thank you so much for letting me interview you.
Recognized internationally as a trailblazer in neutrino physics, Wang's research work in particle physics has not only provided us a window into the mysterious origins of our universe, it has also led to new discoveries benefiting mankind.
The quest for the secrets of neutrinos is not finished yet, and many more mysteries yet to be discovered. Particle physics sometimes is also called high-energy physics. So we want to understand what are the fundamental elements which made of the material world. In the process of this kind of studies, we actually invented a lot of tools, and these tools are useful also for our daily lives. For example, nowadays there are more than 35,000 accelerators in the world, more than half of them in the hospital. And also there are large infrastructures made of using accelerators to study the structure of materials, to study the chemical reactions. So from science to our daily life, there are a lot of applications.
After obtaining his bachelor's degree in physics from Nanjing University, Wang was one of the few candidates selected by Nobel laureate Professor Samuel Ting to join his experiment at CERN, the European Organization for Nuclear Research in Geneva.
Everybody knows that he is a great scientist, and I had a chance to study from him. I think this is a really a great opportunity for my life. So, of course, I'm very excited. I work on the detector design and construction. I think that's a requirement for a good, say, particle physicist. You have to design your apparatus for your scientific purpose. So this is the control room. When accelerator is running, we can see the status of the accelerator. And then the detector is collecting data from the collision.
Always wanting to challenge himself and expand his experiences, after 11 years, Wang left his mentor and joined Stanford University in the United States.
So I want to work on something I can put my hands on it and I can design in my way.
As Wang settled into a key research position at Stanford, things were also progressing in his personal life. He and his wife bought a house in Silicon Valley and started a family. So it came as a shock to his friends and family when at the prime of his career, Wang decided to return to China. Wang knew in his heart that to achieve the next breakthrough in his career, he had to take this bold step.
Going back home was always an option in my life. Also in China at that time, we realized that there are a lot of opportunities.
Wang's first major project back home was the Beijing Spectrometer 3 and the Beijing Electron-Positron Collider 2, a crucial part of the collider designed and constructed to the highest technical standards and helped discover a series of new particles and phenomena. Wang then proceeded to conceptualize and construct the Daya Bay reactor neutrino experiment for neutrino studies.
There are a lot of challenges and difficulties for the design and the construction of this experiment. But you have to have a way to get the best sensitivity. We had trouble with power plant to dig the tunnel because we are doing the blasting very close to reactors, and there are strict controls for safety. And also when we built our detector, we had many technical problems, which actually made us very frustrated during the process. But anyway, in the end, we overcome all the problems one by one and managed to have a successful experiment.
His efforts paid off when his team became the first in the world to discover a third kind of neutrino oscillation in 2012.
When our results reached the community, I think everybody got very excited because they all know how important it is.
Even as Wang and his team's achievements have received international recognition, he knows there is still a long road ahead.
Achievement we had in the past few years that we managed to develop our own photon detectors.
This is a photon detector.
This is a photon detector, so single photon, single photon. So photons comes in, they can be absorbed and then converted into single electron and then amplified. So one electron becomes 1 million electrons.
The homegrown photon detector is a crucial piece of equipment for Wang's next project. Situated 700 meters underground is a cave filled with 20,000 tons of liquid scintillator surrounded by photomultipliers. This is Juno, or the Jiangmen Underground Neutrino Observatory, slated to begin detecting and recording data in 2022. Not only is it the most complex high-energy particle facility in China, Juno is 20 times bigger than its international counterparts and promises to improve the precision of oscillation parameters by 1 order of magnitude.
Our concept came out in the international community. There are a lot of people doubted our design and they believe you are not able to achieve the main goal of your performance of your detector. And there are also people doubt that you are not able to build such a large detector. Believe that we are expert of this field. We got a lot of attention from international community. We have now 17 countries, 77 research institutions, and more than 600 scientists and engineers are the member of the collaboration. I think the fact that we're able to attract so many international partners into the collaboration shows that scientifically this is a very good experiment.
Wang's curiosity to the world never stops. To reveal the remaining mysteries of our nature, his next goal is to construct the world's biggest particle smasher at home. Besides being a dedicated researcher, Wang is always keen to mentor younger counterparts. Following his footsteps, a group of up-and-coming scientists are ready to pick up the baton to pursue the next level of scientific breakthrough back home. Dr. Cao Jin is one of them.
Wow, what is this place?
Yeah, it's a laboratory for the prototype testing for neutrino experiments, Diabe and Juno. So sometimes we need a new technology to be used in the experiment, and we need to test and verify this technology with a smaller detector. This kind of experiment is very necessary because you design and plan everything on paper, it may not work. It may not work as you thought.
So you have to make sure it works.
And find the worst problem.
Cao has been with the Diabe reactor neutrino experiment since 2003 and now leads the experiment as a co-spokesperson.
I was very young that time. I can design and construct an experiment, start from scratch. That's a very rare chance. So I think I have to grab this chance.
Cao's efforts in particle physics research has won him numerous awards. He credits Wang for inculcating the forward-looking approach in experiment.
We often make mistakes that by looking in the future with our current point of view, it's very difficult to change our mind. I think Yifan is very good at looking into future in a future environment. There are several impacts to me.
Under Dr. Wang's leadership, the Institute of High Energy Physics has attracted numerous young physicists, a next generation of homegrown scientists in the making. An admirer of Dr. Wang's, Wen Liangjian, wrote to ask for an opportunity to study under him for his doctorate degree. In 2016, Wen's achievements in neutrino research was affirmed with the Young Scientist Prize from the International Union of Pure and Applied Physics. This was the first time a Chinese particle physicist was awarded this prize.
I hope I can continue make significant contributions to the field and be a respected scientist internationally. As Professor Yifan Wang said, they want to see more Chinese scientists' name in physics textbook. I really hope I can be one of them.
Dr. Wang's relentless pursuit of science and his constant push to venture into the unknown is remarkable. Time and time again, he has proven that he and his team can achieve what is thought to be impossible. He strongly believes in his country's potential to be a leader in the world of science, and he's confident of China's capabilities. His discoveries and his visionary spirit is impacting the scientific community, and hopefully it will inspire all of us as well.
I hope our new detectors will be technological breakthroughs in the world.
I hope that one day I can design my own experiment, build my own experiment, and through that, discover new things about our universe.
I hope through our future experiments, we will discover more profound mysteries of the universe.